Hello, college algebra student. This video is for chapter 2.5, part 3. Continue with solving quadratic equation. In this section, we are looking at how we can use graph to solve quadratic equation. Algebraic methods, all the algebraic method was covered in part 1 and 2 of the 2 videos. But nowadays, calculators and online tools are so popular. If we are to solve a quadratic equation, it's very easy to use graphing. So we like to actually relate an equation with its graph and to understand how we can solve it. So what happened is, the key idea is, if we want to solve a quadratic equation of ax squared plus bx plus c equal to 0, it could be factorable, it could be non-factorable, or whatever. We can actually use the graph to find the exact solution or the approximate solution. So the idea is, this is the equation. It only has x. That's how we can solve for x, right? But we can graph it by pretending I'm graphing an equation of y equal to ax squared plus bx plus c, meaning we are replacing the 0 by y. So the equation would be solved when y is 0. Just imagine if you are to solve a equation where y in a graph when y is 0, that is when it is on the x-intercept, on the x-axis, right? So if this is a graph, whatever graph that you have, it could be like this, right? So whenever we graph an x squared equation, it's a parabola. It would be either going up like this or going down. And what happened is, this 2x-intercept, if it exists, would have a y equal to 0. So that is our equation. Y is equal to 0. So the 2x-intercept would be the solution. So let's do an example. I want to solve 5x squared minus 2x minus 6 equal to 0. I don't know what x is. So instead of using algebraic technique that we do from A to D method, we're going to use graphing. We can use decimal, which is an online graphing calculator. So we'll fire up here. We have a decimal. So if you don't know how to get it, you can Google decimals, and then this will show up. Okay, graphing calculator. And then you just type the equation. But the equation has to have y, because otherwise it would not be a line. So it would be y equal to 5x squared minus 2x. Is it plus 6 or minus 6? Minus 6, right? Let's look at minus 2x minus 6. So I don't type the equation equal to 0. I type y equal to 5x squared minus 2x minus 6. And decimal will graph it. In our case, they graph it in purple. And we can zoom into by just, zooming into clicking it, and it would show up. I can also show it larger by a better contrast by using projector mode. And these are the 2 x-intercept, because this is the origin, right? So this is the origin. You look at it, this is the origin, and we have 2 x-intercept. So this is when y is 0. So if you click on it, decimal will know that, oh, they're trying to find the x-intercepts. So I have 1.314, comma 0. 1.314. So they're usually given in 3 decimal places, negative 0.914. So this would not be the exact value with square root and stuff, but it would be an approximate value. And then you can copy it down and graph it. Okay, so it's 0.9, 1.3. So you can graph it, sketch it. So negative 1, 1. So that one is negative 0.9, 914, comma 0. And this x-intercept is 1.314, comma 0. And you can graph it. And so you would say x is equal to negative 0.914, comma 1.314. Round to 3 decimal places. If you want more decimal places, you zoom in more. So this is how you can solve a quadratic equation, by graphing. Look at the x-intercept. Now what happens if they don't have an x-intercept? Can I still graph? Can I still solve it? Say, for example, if I do 5x squared, actually earlier, I was trying to do this one. So I am going to my decimal over here. So I was trying to actually do a +6, but when I graph it, I can't see the graph. Where is it? Let's zoom out. Oh, it is up here. It's not touching the x-intercept. That means it's not that it has no solution, it has no real solution. So if you solve this by hand, you would see that it has a solution that is I. I is not a real number, so that's why it doesn't touch it. So it is no real solution. So I can actually get something over here and say, maybe I'll just say example 2, solve. If I want to solve 5x squared minus 2x plus 6 equal to 0, I graph 5x squared minus 2x plus 6 equal to y. There is no x-intercept, no real solution. So if you want to find the complex solution, you have to do it by hand. Now, how can you not looking at the graph and determine that there is no real solution? Because sometimes this is something that you want to solve, in real life. And it would be nice if I just know that, oh, there's no x-intercept. It has no real solution. It's not a real number. So the way you can do it is by checking something called a discriminant. A discriminant is in the quadratic formula, the b squared minus 4ac part. If the discriminant, sometimes we abbreviate as d, is equal to b squared minus 4ac, if this is a negative number, you would know that, oh, in the quadratic formula, you have x equal to negative b plus and minus a square root of a negative, right? If this is less than 0, this is the b squared minus 4ac. If it's negative, you must have I, right? 2a. So this is negative, means the solution is complex. It's not real. So sometimes you can just check b squared minus 4ac. Don't square root it, just do b squared minus 4ac. If it's negative, you would know that the solutions are not real. Or that should be two solutions. Solutions are not real. So that is this part about graphing and also figuring out if you have a real solution or not. The next part is the last part. In the book, this is part of 2.6, but I move it to 2.5 because it's really related to this section. So we are continuing with our solving rational equation. That means your unknown is in the denominator. But this particular types of equation will result in the equation is quadratic. So let's see how we can solve it. Still remember how we do it in 2.2? We say if we want to solve something that has denominator, we factor all the denominator and then find LCD, right? So factor this first, x squared plus x minus 2. We can use diamond, negative 2 and 1. 2, negative 1, I guess. So it will be x plus 2, x minus 1. This actually gives you a hint. This is x plus 2 and x minus 1. So you can write this as 3 over x plus 2, x minus 1. Now, obviously, the LCD is all the common factor, right? So LCD is x plus 2, x minus 1. So everybody convert to this. So this would be converted as x times x minus 2 over x minus 2, x minus 1. No, x plus 2. X plus 2. And then this one need to multiply with x minus 1. 1 times x minus 1 over x minus 1, x plus 2. So everyone has the same common denominator, right? And then we say, well, we can then multiply with the LCD to clear them. Multiply x plus 2, x minus 1 for all of them. So we will cancel all of this. All of them cancel with this. So it becomes x times x plus 2 is equal to, no, plus, plus x minus 1 equal to 3. Okay, so this is the equation. And you see that this is a quadratic equation. X squared plus 2x plus x minus 1, you distribute this, equal to 3. Okay, so now combine like term, x squared plus 3x minus 1 equal to 3. I minus 3 on both sides, so it'll be x squared plus 3x minus 4 equal to 0, right? Minus 3, minus 3. So this is obviously factorable. Negative 4 and 3. 4 times negative 1, right? So it'll be x plus 4, x minus 1. When you multiply them, they are negative 4. When you add them, they are 3. So equal to 0. So x is equal to negative 4 and x equal to 1. You see how this was similar to chapter 2.2's equation, but it became a quadratic instead, and then I can solve it. Now, do I have two equations? No. What happened is when you have this kind of equation, you have to exclude what? You have to exclude some x value. It cannot be divided by 0, right? You cannot have you would have do not allow x equal to 1 because you divide by 0. And you also need to exclude negative 2. So this would be excluded. So the only solution is x equal to negative 4 is the only solution. So this is solving rational equation by using some of the method that you use to solve quadratic equation.